This is section 3.4 continued. I am on page 4. Part C. Says to take the derivative as the directions on the previous page. And I'm just going to go ahead and rewrite this as 2 times quantity t squared minus 1 to the negative fifth. So if you notice, we have an outside function and we have an inside function. So going ahead and taking the derivative, put g prime of t, we are going to have the derivative, keeping the inside the same, is going to become negative 10. Leave the inside function the same, t squared minus 1. Subtracting 1 from the exponent is going to become negative 6 times the derivative of the inside, which is 2t. From here, I'll let you guys clean this up. There is no negative exponents allowed, so you want to make sure you rewrite that. For part D, we're going to go ahead and find f prime of theta. And you have an inside function, just like how we had an inside function over here. So taking the derivative of secant, the derivative of secant is going to be secant theta tangent theta, but we don't just have theta here. We have secant of 2 theta squared times tangent of 2 theta squared times the derivative of the inside function, which is going to be 4 theta. It's not too much to do to clean it up, but you can write it a little bit nicer. Put that 4 theta in the front. For part E, we have sine x quantity squared plus e to the x squared minus 1. So we have 2 different functions here that both are going to require the chain rule. So we put dy dx, or y prime, something to show that you are now taking the derivative, and this is the derivative answer. So taking the derivative of the first term, it's sine x, which is our inside function, squared. So using the chain rule and the power rule, we're going to have 2. Leave the inside function the same, so sine x, to the first times the derivative of sine, which is cosine of x, plus we have e to the x squared minus 1. That x squared minus 1 is our inside function. So taking the derivative of e, it's just e, leaving the inside function the same, times the derivative of the inside function, which is 2x. From here, you guys can clean this up. Check on Canvas. There's a couple different ways to write your answer and still be okay. The next problem is f. And f, you have an inside function is sine x here. And then the second one, we have an inside function, which is f of x. So if you notice, there's an outside and an inside for both of these. So go ahead and put dy dx, or y prime. Take the derivative of the outside, will be f prime. Leave the inside function the same, times the derivative of the inside function, which is going to be cosine of x, plus the derivative of the outside function, sine, keeping the inside the same, is going to be cosine of f of x, times the derivative of the inside is going to be f prime of x. The next one down here is part G. And part G says h of x equals 2x times x squared minus 1 to the 1/3 power. Rewriting that. I want you guys to realize this time we are multiplying 2 things that involve an x. And then you also have, on the second part of this, you have an inside function and an outside function. So we're going to have to use the product rule and the chain rule. So h prime of x equals, so we have the first term times the derivative of the second term, which is going to be 1/3. Leave the inside function the same. Subtract 1 from your exponent, you're going to get negative 2/3, times the derivative of the inside, which is going to be 2x, plus the second term, which is x squared minus 1 to the 1/3, times the derivative of the second, which is 2. From here, you guys can clean this up quite a bit. You'll notice that we can factor out a GCF. We have GCFs of x squared minus 1 and of a 2. So see if you can keep going and simplify that. And then also start looking at part H. H is sine, and you have an inside function that's going to require you to use the quotient rule. Check your answers on Canvas.